Welcome Algebra 2. This is section 11-1, Permutations and Combinations. The essential question is, what is the difference between a permutation and a combination? Let's begin. So, for example, let's say you had this lunch special here where you get one entree, one side, one drink. How many meal choices do you have? So you go pizza, salad, soda, or go chicken, salad, water. A lot of different choices. There's a formula, a rule that you can use to figure out your choices. It's called the fundamental counting principle. So it says if there are n items and m sub 1 ways to choose a first item, m sub ways to choose a second item, etc., then you multiply those ways together, and that's the number of ways to choose. So basically, multiply your choices together. So for example, there's 3 choices per topic, and there's 3 topics, so it's 3 for the entrees times 3 for the side drinks times 3 for the drinks, and your total would be not 37 choices, 27 choices. All right. Let's look at another example of that. So a password is 4 letters, all lowercase, followed by 1 digit. How many passwords are possible? So it could be A1, could be a possibility, or A2, and so on. Well, you got five characters here, right? The first 4 are going to be letters, they're all lowercase. And each character, you have 26 opportunities, 26 letters in the alphabet. So each of these is going to be 26. Now for digits, digits are 0 through 9. There are a total of 10 digits. So to figure out my possibilities, I have to multiply 26 times 26 times 26 times 26 times 10. And if you did that, your answer would be something really big. It's 4,569,760. And that's how many password combinations there are. All right. Another concept here, factorial. This is going to be important. So factorial is where you do a number n and an exclamation mark. And what does that mean? It means you multiply all numbers together starting with that number and then count down. So example, if you had 5 factorial, you would multiply 5 times 4 times 3 times 2 times 1, all the way down until you get to 1. And so what would that be? Well, 5 times 4 is 20, 3 times 2 is 6, 1 doesn't matter. So 20 times 6 would be 120. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. 6 times 5 is 30. 4 times 3 is 12 times another 2. And 12 times 2 is 24. 30 times 24 is going to be 720? 720. Exactly. Now let's say you want to do 4 factorial. 4 factorial will be 4 times 3 times 2 times 1. So 4 times 3 is 12 times 2 is to be 24. So that's how that works, just counting down. So that's important when we want to do permutations and combinations. So permutations, what does that mean? It's how many ways you can order a group of objects. So for example, if a red-blue, like if I had 2 circles here, I want to order red first then blue, that's going to be different from ordering blue first then red. So the order matters when you're ordering things in permutations. All right? That's the big thing here. You have to count the red first then the blue, and also the blue first then the red. So let's do here's the formula for permutations. The number of permutations of n items taken r at a time is, our notation is, you do a little n p little r equals n factorial over n minus r factorial. So, and you have to understand, if you have n items, so like say you have 5 characters in a password, and how many of those are you going to choose from? Actually, that was a bad example. But anyways, if your n is 10 and your r is 4, you're just substituting those in. So it's 10 factorial over 10 minus 4 factorial, which is 10 factorial over 6. Now, if you want to simplify that, one way is to write all those out. And you'll figure out other shortcuts as we do this more, and I'll show them as we go. So I expand all that out, and I expand the 6 on the bottom. 5 times 4 times 3 times 2 times 1. So you multiply that out, and I'd cancel what matches the top and bottom, which is the 1s, 2s, 3s, 4s, 5s, and 6s. So then all you're left with is 10 times 9 times 8 times 7 on the top, which is going to be 90. 10 times 9 is 90. 8 times 7 is 56. So 90 times 56, if you're multiplying that out, you're going to get 4, carry a 5, 50, 40. 5,040 would be the number of permutations in that case. Let's actually apply this. So let's say, for example, you have 5 M&Ms, and you want to pick 2 in order. So how many different picking orders can you make? So 5 M&Ms, green, brown, red, blue, and yellow. So I can make a table and list all those out, and the order does matter. So green first, then brown. And maybe the next one would be a green, then red, and a green, then blue, and green, then yellow. And then, okay, I can start with the brown first. So brown, then green. So that's different from green, then brown. And then you get brown, then red, and brown, then blue, and brown, then yellow. And if you kept doing this, you'd figure out that there are approximately, I think there's approximately 24 or so. And you could always make a table. But let's see if we can actually use that formula that we just saw. So, n is the number of items. How many items do you have to choose from? In this case, there's 5. And how many are you picking? You're picking 2. So your n is 5 and your r is 2. I'm going to substitute that in. Get 5 factorial over 5 minus 2 factorial, which becomes 5 factorial over 3 factorial. And if I expand that out, 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. I'm going to cancel out the 1s, the 2s, and the 3s. I'm left with this 5 times 4 on top, which is 20. So there's 20 different options. And you could have made that table or just use this formula. Both will get you the same number. Let's try another example. 10 students are in a race. First, second, and third places will win medals. In how many ways can 10 runners finish first, second, and third, and no ties are allowed? So the neat thing is when we're talking about first, second, and third, we are picking 3. But the order does matter, because it matters if you're first place or you're second place or third, because that's being in first place is different from being in third place. And you have 10 students total. So if I'm going to use, this is going to be permutation because order does matter. And our n is going to be 10, and the number we're picking is going to be 3 because there's 3 metals. So it's going to be 10p3, which is going to be 10 factorial over 10 minus 3 factorial, which is 10 factorial over 7 factorial. Now here's some neat shortcuts. I don't have to write those out. I want to go 10 times 9 times 8 times 7 all the way to 1. And this is 7 all the way to 1. So instead of writing those out, I say, oh, 7s to 1s cancel. So you're left with this 10 times 9 times 8 on the top. So that's going to be 9 times 8 is 72, times 10 will be 720. So 720 different combinations. All right, try another one. Or actually, we're going to go to combinations. So combinations are different. It's how many different groups can you make? That's the question you're asking. Combination is grouping items, and order does not matter. So red-blue is the same thing as blue-red. You only count one of these. So I'd only count the red-blue, and I just wouldn't bother counting the blue-red. So the order does matter. And the neat thing is combinations, you should get a smaller number than permutations. Or the combinations, the order does not matter. So the formula for combinations is a little bit different. N factorial over r factorial times n minus r factorial. So if we had 10c4, it'd be 10 factorial over 4 times factorial times 10 minus 4, which is 10 factorial over 4 factorial 6 factorial. And I'd expand these out, 10 times 9 times 8 times 7 times 6 all the way to 1. And then you got 4 times 3 times 2 times 1 times 6 all the way to 1. So I'd cancel things out on top and bottom just to simplify it. 6 to 1s cancel. 1s never actually matter. And here's the thing. You can cancel out and reduce with these multiplications. So I know 4 times 2 is 8, which will cancel out with that 8. I know this 3 and 9 can both be reduced by 3. So that 3 cancels and that 9 turns into a 3. So I'm left with 10 times 3 times 7 on the top, which is 3 times 7 is 21, times 10 is 210. All right, let's actually do an example of that. So the swim team has 8 swimmers. 2 swimmers will be selected to swim in the first heat. How many different combinations of swimmers can be selected? So what's the number of items? Well, you have 8 swimmers total. How many are you taking? 2 of them. Does the order matter? No, because it doesn't. They're both swimming in the first heat. I don't care which order I choose them, because they're both going to be doing the same thing. So that's why I use combinations. It'll be 8CR. So 8CR, well, we can, instead of writing R, we can write 2. So 8 factorial over 2 factorial times n minus r, so 6 factorial. This will be 8 times 7 times 6 to 1. And then 2 times 1 times 6 to 1 on bottom. So what you're going to do, cancel the 6 to 1s. 1s don't matter. And 2 and 8 reduces to 4 on top. So 4 times 7 is going to be 28 different combinations. one thing to note, if you don't know which one should be n or r, n is always the bigger number. And r is always the smaller number. Because you can't choose more than what you have. Alright. Let's look at this. So how do you know when to use permutations or combinations? It's not always going to be obvious or told to you. The question you ask is, does the order matter? If it does matter, you choose permutations. If it doesn't matter, you choose combinations. So you have to think logically. Would it make sense? Does it matter which order do I pick people in? All right, let's do some problems. Go. Okay, practicing this. I'm going to go 8. This is going to be 8 factorial over 3 factorial times 8 minus 3, so 5 factorial, which expands to 8 times 7 times 6 times 5 to 1 over 3 times 2, I don't need to write 1, times 5 to 1. Canceling out the 5 to 1s, 3 times 2 is 6, that cancels out the 6. 8 times 7 is left on top, so that's 56. For permutations, 8 factorial over 5 factorial, which comes out to 8 times 7 times 6 times 5 to 1 over 5 to 1 on bottom. And the 5 to 1s cancel, so you're left with 8 times 7 times 6, which is 56 times 6, which is going to get you 6 times 6 is 36, carry a 3, is going to be 336. All right, last example. Pause the video. All right, combinations 5 choose 5. So it'd be 5 factorial over 5 factorial times 5 minus 5 factorial. That's going to be 5 factorial over 5 factorial over minus 0 factorial. 0 factorial is actually equal to 1. So if you don't know what that is, it's not 0, it's 1. So this is going to be 5 factorial over 5 factorial, because that just cancels, it's 1. And same thing over same thing, that just reduces to 1. There's one combination when you have 5 and you choose 5. Permutations, 4 factorial over 4 minus 3, so 4 minus 1 is just 3 factorial, which expands to 4 times 3 times 2 times 1, 3 times 2 times 1. And what cancels out is a 3, 2, 1. You're left with 4, and that's your answer. Done.